Hey friends, today we are going to solve the second section of ICSE Physics 2017. You have to attempt any four, but I will solve all the questions for you. If you do like the video, hit the thumbs up and the subscribe button. Question number 5a. A uniform half meter rule balances horizontally on a knife edge at 29 centimeter mark when a weight of 20 GF is suspended from one end. We have to draw a diagram of the arrangement and then we have to find the weight of the half meter rule. So the arrangement will be like this. Draw a half meter rule, half meter, that is 50 centimeter. Got it? Yeah. And it is balanced at a 29 centimeter mark. So let this be 29 centimeter and this is the fulcrum point. Okay. And a weight of 20 GF is suspended from one end, right? Now we know an empty rule. An empty half meter rule will be balanced at the mark 25 centimeter as the fulcrum point has shifted to the right hand side. I will show you with the help of a ruler. मैं आपको एक 15 सेंटीमीटर स्केल से दिखाना चाहता हूँ कि ये 7.5 सेंटीमीटर के मार्क पे बैलेंस्ड हो रहा है. अगर मैं एक वेट इस साइड रखता हूँ तो ये नीचे की ओर बेंड कर रहा है, ठीक है. और अगर मैं इस फलक्रम को इस साइड मूव कर रहा हूँ तो ये और भी ज़्यादा बेंड कर रहा है, ठीक है. तो मुझे इसे बैलेंस करने के लिए इसे वेट के तरफ ये करना होगा, मूव करना होगा फलक्रम को. इसीलिए क्योंकि जो हमारा मिड फलक्रम पॉइंट है वो राइट हैंड साइड शिफ्ट हुआ है तो हमारा जो लोड है वो इस साइड होगा, ठीक है. तो हम अब लोड को इस साइड ड्रॉ करेंगे, ठीक है, जो कि है 20 GF. तो आपका डायग्राम कुछ इस तरीके का होगा, ठीक है. ओके. The next question is to find the weight of the half meter rule, right? Weight of the half meter rule. We know clockwise moment is equal to anti-clockwise moment by the principle of anti-clockwise moment, right? By the principle of moments. Got it? So clockwise movement, that is this side, that will be, you see, 4 centimeter difference, 29 minus 25 into weight of the rule is equal to weight into 50 minus 29. Got it? So this will be 20 into 21 and this will be 4 into m, that is m equals 20 into 21 divided by 4, that equals 105 gram. Got it? So this is the weight of the rule. B1 is a boy uses a single fixed pulley to lift a load of 50 kgf to some height. Another boy uses a single movable pulley to lift the same load to the same height. We have to compare the effort applied by them and give a reason to support our answer. Okay. Now, if you know mechanical advantage of a single fixed pulley is 1, okay, and mechanical advantage is the ratio of load by effort. Okay, so in case of single fixed pulley, load will be equal to effort. Okay, that is effort will be equal to load, that is 50 kgf. In the second case, that in the case of single movable pulley, mechanical advantage equals 2, that is L by E equals 2, and so effort will be equal to half the load, that is 50 by 2, that is 25 kgf. Okay, so if we mark effort 1 as E1 and the second one as E2, the comparison will show you that the ratio will be 2:1, right? Now we have been asked to give a reason too. Now we see that mechanical advantage is greater than 1 for single movable pulley, and if you remember in machines mechanical advantage greater than 1 belongs to second class, that is the machine acts as a force multiplier. So as the force will be multiplied, therefore the effort required will be less. That will be your reason. Got it? In part 2, how does uniform circular motion differ from uniform linear motion? Okay, uniform circular motion differs from uniform linear motion. Now what is uniform circular motion? A body moving in a circular path with a constant speed is known as uniform circular motion. Got it? And a body moving in a linear path with constant speed is known as uniform linear motion. Okay, now in uniform circular motion, velocity is variable, because you see in a circular motion the tangent always changes, that is the direction always changes, hence the velocity is variable. Got it? But in the case of uniform linear motion, velocity remains the same. Velocity remains the same. Got it? Also acceleration, this uniform circular motion will be accelerated motion, but uniform linear motion will be unaccelerated motion. Got it? So these are the differences between the uniform circular motion and uniform linear motion. Got it? 3. Name the process used for producing electricity using nuclear energy. That is nuclear fission. Got it? C. A pulley system with velocity ratio equal to 4 is used to lift a load of 175 kgf through a vertical height of 15 meter. The effort required is 50 kgf in the downward direction. Distance, we have to calculate distance moved by the effort, work done by the effort, mechanical advantage and efficiency. Okay, now we know velocity ratio equals distance moved by the effort by distance moved by the load. Distance moved by the load has been given 15 meters. Okay, so velocity ratio equals, and velocity ratio has been given 4. So 4 equals distance moved by the effort divided by 15. That will give us distance moved by the effort equals 15 into 4 equal to 60 meters. Okay, this is number 1. Next we have to calculate work done by the effort. Now work done by the effort equals effort into distance moved by the effort. Effort has been given over here 50 kgf and 50 kgf, that is 15 to 10 500 Newton into distance moved by the effort, that is 60. Okay, so 5 6 30,000 joule will be the mechanical advantage equals load by effort, right? Load has been given 175 kgf and effort has been given 50 kgf. Okay, by 25 2s are 50 and 25 7s are 175. That will give us 7 by 2 3.5. Got it? Since mechanical advantage is the ratio between two same quantities, so it will not have any unit. Got it? Now 4 is efficiency. Efficiency equals mechanical advantage by velocity ratio into 100, right? Mechanical advantage we have found out that 3.5 and velocity ratio is 4 over here into 100. Got it? So this will be 25 5s are 125 ka 5 carry 12 5 25 3 is 75 75 and 12 87.5% will be the answer. Okay, moving on to question number 6. A1. How is the transference of heat energy by radiation prevented in a calorimetry? Now, to prevent the loss by radiation, conduction and convection, different methods are applied. To prevent the loss of heat energy by radiation, the inner and outer surfaces of calorimeter are polished. Got it? To prevent the loss of heat energy by radiation. Got it? Number 2. You have a choice of 3 metals A, B and C. Of specific heat capacity is 900 joule kilogram per degree centigrade, 380 joule per kilogram per degree centigrade and 460 joule per kilogram per degree centigrade respectively. To make a calorimeter, which material will you select? Justify your answer. Now the material having the least specific heat capacity will be chosen as the material for calorimeter. Over here 380 joule per kilogram per degree centigrade is the minimum, so it will be chosen as the material to make the calorimeter. The reason will be the material required should have low specific heat capacity so that the heat energy taken by the calorimeter from its contents to acquire the temperature of its content, is negligible. Have you got it? Calculate the mass of ice needed to cool 150 gram of water contained in a calorimeter of mass 50 gram at 32 degrees centigrade such that the final temperature is 5 degrees centigrade, and specific heat capacity of calorimeter, water and latent heat of ice has also been given. Now these are not the general sums that comes in ICSE, but these had come in 2017, so we are going to solve this. Now to solve this sum, you must note the data given. Let mass of water given be 150 gram. The specific heat capacity be denoted by Cw equal to 4.2 joule per gram per degree centigrade, and mass of ice to be found out, Mi. Got it? Then latent heat capacity L has been given 330 joule per gram. If no heat is lost in the surrounding, then we know by the principle of calorimetry, heat energy lost by hot body is equal to heat energy gained by the cold body, right? Over here, hot bodies are calorimeter and water, so they will release heat, and the cold bodies are ice. Heat energy gained by ice in melting, right? And the melted ice will also gain heat energy to change its temperature. Heat energy gained by melted ice to rise in temperature. By simple deduction on the above given data, we will get L equal to this expression. That will give us 330 equals 50 into 0.4 plus 150 into 4.2 into 27 divided by M3, that is mass of the ice we have to find out, and this is Cw, that is heat capacity of the water 4.2, and the change in temperature, that is 5 degrees centigrade. So 42 into 5 is 21. Okay, now 330 plus 21 is 351 equal to, this will be 20 plus this will be 0, 12 5 is 30 is 0, carry 3, 15 4 is 60 and 63. Got it? And this is 27. This is M3 minus 200, so this will give us 351, cross multiplication M3 minus 351 200, that is 2, 2 1s are 2, 5 2s are 10, 0, carry 1, 3 2s are 6 1, 7. Got it? And on solving this, 27 into 20, that is 540, and 27 0, 27 3s are 81 ka 1, carry 8, 27 6s are plus 8, that is 175. Got it? So this will be summed to get 17550. Got it? So from here 351 M3 equals 17550 plus 70200. So M3 will equal, this will be added to get 50, 5 to 7, then again 7 and 8. Okay, and divided by 351. M3 equals 87750 and divided by 351. 351, this will be 2 ones are 2 and 35 2s are 70. Okay, 7 to 5, this will be 7 and 1. Okay, on putting 5 over here, we see 5 are 5 ones are 5, 5 5 is 25, 5 carry 2, 5 3s are 15 and 2 70. It's over and 0. So this will be equal to 250, and since it is mass, so it will be gram, 250 gram. That's all. C. 1. Name the radiation which are absorbed by greenhouse gases in the Earth's atmosphere. Now, greenhouse gases absorb infrared radiation of long wavelength. Okay, so that is why resulting in the increase in the temperature of the Earth's crust. Number 2 is a radiation X is focused by a particular device on the bulb of a thermometer, and mercury in the thermometer shows a rapid increase. Name the radiation X. Now, infrared radiations emit maximum heat radiation, so infrared radiation will be the responsible cause of the increase in the temperature. Number 3, name 2 factors on which the heat energy liberated by a body depends. Now, QE equals mc delta T. Got it? That is, heat depends upon mass and specific heat capacity. Got it? So the 2 factors will be mass of the body and specific heat capacity of the body. How does it depends? Greater is the mass of the body you want to heat, greater will be the heat energy required, and greater is the specific heat capacity of the body, greater heat you have to apply. Got it? Question 7a. A lens forms an upright and diminished image of an object when the object is placed at the focal point of the given lens. We have to name the lens and draw a ray diagram to show the image formation. Now we know for a concave lens, when the object is placed between infinity and optical center, the image formed will be upright and diminished. Therefore, it will be the same for an object placed on focus. That is, our answer will be a concave lens. The lens will be concave, and we have to draw a ray diagram to show the image formation. So the image will be as, draw a concave lens. Okay. This is f1, this is 2f1, the object is at focus. Got it? Now a ray will be, and will pass along this. Got it? So when it is produced backward, an image, a small diminished upright image will be formed over here. Okay, let this be AB, so the image formed will be A dash B dash. Do not forget to mark the arrows. Got it? So this is the diagram. Next we have B. A ray of light travels from water to air as shown in the diagram given below. We have to copy the diagram and complete the path of the ray, and we have to, given the critical angle for water is 48 degrees. Okay, so the ray is incident at 48 degree. This is the case where incident angle equals critical angle, so the refracted ray will make an angle 90 degree, that is pass like this. What is that? Is in between the two medium, it will pass. Got it? This is the complete ray diagram. Next we have to state the two conditions so that total internal reflection occurs in the above diagram. Now when the angle of incidence is equal to critical angle, the angle of refraction will be 90 degree, and when the angle of incidence will be greater than critical angle, the ray will be totally refracted into the same medium, that is total internal reflection will occur. So one condition will be angle of incidence will be greater than, should be greater than critical angle. Also the ray must pass, the ray of light must pass from denser medium to rarer medium. Got it? Next, C. The diagram below shows a point source P inside a water container. Four rays A, B, C and D starting from the source P are shown up to the water surface. We have to show in the diagram the path of these rays after striking the water surface, and the critical angle for water air surface has been given 48 degree, and we have also to name the phenomena which the rays B and D exhibit. Okay, let's draw the diagram. This is A, this is B, this is C and this is D. Okay, this angle has been marked 48 degree. This is C and this is B. Okay, now we have to complete, so in the ray diagram, the path of these rays after striking the water surface, right? So here the refraction is going to occur. Since water is denser than air, so it will bend away. If we draw a normal over here, so it will bend away from the normal. Okay, in C the angle of incidence is equal to critical angle, so the refracted ray will make for 90 degree angle with the medium. Got it? And over here the angle of incidence is greater than critical angle, that is the ray will totally be refracted into the same medium. Okay, in the first one the ray will move straight. Okay, so this is the completed diagram. Next we have to name the phenomena which the rays B and D exhibit. In B, refraction occurs, B, and in D, totally, this is D, where the ray was totally refracted. This is total internal reflection. Question 8. Name the factor that determines, number 1, loudness of the sound heard. Now loudness depends upon many factors, but one of the main is amplitude. Second one is quality of the note. Now quality of the note mainly depends on relative amplitude. Relative amplitude. 3. Pitch of the note. Pitch of the note mainly depends on wavelength, and if it depends on wavelength, then it will also depend on frequency. Okay. What are damped vibrations? Now damped vibrations are those periodic vibrations of a body of decreasing amplitude in presence of resistive force. Okay, so this is called damped vibration. Okay, next we have to give one example of damped vibration. Okay, tuning fork vibrating in air is an example. We have to name the phenomena that causes a loud sound when the stem of a vibrating tuning fork is kept pressed on the surface of a table. Of course, that is damped vibration. Not damped, probably, you can say forced vibration, right? Next, C. 1. A wire of length 80 centimeter has a frequency of 256 hertz, we have to calculate the length of similar wire under similar tension, which will have frequency 1024 hertz, right? Let its length at initial length be 80 centimeter, initial frequency be f1, 256 hertz. Let's initial tension be T1. Okay. So according to question, the tension is similar in both the cases, that is T1 equal T2. Okay. So 4mL1 F1 square will equal 4m2 L2 F2 square. Right. Now mass will remain the same, so it will be cancelled out. And putting the values of L1, that is 80, F1, that is 256 into 256. 4 can also be cancelled, no need to write 4. L2 we have to find out, and F2 is 1024 into 1024. Now 256 4s are 1024. Okay, and this will cancel this as 20 and this as 5. So L2 will be equal to 5 centimeter. Okay, next 2. A certain sound has a frequency of 256 hertz and a wavelength of 1.3 meters. We have to calculate the speed with which his sound travels. Right. Now, we know speed, velocity equal to frequency into wavelength. Frequency is 256 and wavelength is 1.3. So 13 6 is 78, 8 carry 7, 13 5 is 65, 7 72, 2 carry 7, 13 2 is 26 and 7 33. 1 point will be over here, that will be equal to meter per 332.8 meter per second. Okay, now next second part asks us what difference would be felt by a listener between the above sound and another sound traveling at the same speed but of wavelength 2.6 meter. Right. Now for second one, that is for second, velocity has been given 332.8 meter per second. We know frequency is equal to velocity by wavelength. Velocity is 332.8 and wavelength is 2.6 na 2.6. That will cancel out as 121 to 8, right? That is 128 hertz. Now we see the first one, the first frequency was 256 and the second frequency is 128 hertz. That is, the frequency has been halved. So the first sound will be shriller than the second one. Okay. Question number 9, A1. We have to name the color code of the wire which is connected to the metallic body of an appliance, and the color code is green or yellow. Right. Next, number 2, we have to draw the diagram of a dual control switch when the appliance is switched on. Right. We have to draw the diagram. The diagram will be like this. Let this be a bulb. Okay. This is live wire. Got it? A, B and C. Got it? This will be on through BC. Okay. In first case we are taking it is on through BC. Okay. And a connection is made through A. This is C, this is B. It will move on from C to B and then to the neutral, and over here it will be supplied. Got it? This is for switch S1. Right, this is the first case through switch S1. Got it? Switch S1. Okay. Now the second case will be through switch S2. Got it? And it will be as, let this be live wire. Okay. make 3 dots, right? This will be A, B and C. Now this will be through second one. The connection will be made from the second switch, right? So this is, and then it will be supplied. So this is through switch S2. Okay, these are the two cases. In B1, which particles are responsible for current in conductors? We all know that is electrons. Which particles are responsible for current in conductors? We know I equal Q by T, that is the rate of flow of charge is called current. So it is a charge or the charge carrier particles, that is electrons, which are responsible for current in conductors. Next, to which wire of a cable in a power circuit should the metal case of a geyser be connected? To which wire? We know it's earth wire. And why? For earthing. The extra charge will go through earth wire to the earth. Got it? The third one is, to which wire should the fuse be connected? To the live wire, for safekeeping, as when the extra amount of current will flow through it, the fuse will melt, break, and will prevent any harmful situation, any dangerous situation. C1. We have to explain the meaning of a statement current rating of a fuse is 5 ampere. The fuse, it means the fuse will allow 5 ampere current to pass through it, and if it gets higher, means if extra amount of current flows through it, the wire will melt. And the connection will be broken. Got it? 2. In the transmission of power, the voltage of power generated at the generating station stepped up from 11 kilovolt to 132 kilovolt before it is transmitted. Why? अब देखिए क्या होता है कि जब वोल्टेज को इंक्रीज किया जाता है तो क्या होता है, करंट रेटिंग जो है वो कम हो जाता है। और हम लोग जानते हैं H इज इक्वल टू आई स्क्वायर आर टी से, अगर आई स्क्वायर का वैल्यू अगर कम होगा तो जो हीट एनर्जी रिक्वायर्ड है वो क्या होगा, कम होगा। एज अ रिजल्ट जो हीट एनर्जी निकलेगा या रेडिएट होगा वो कम होगा। तो वी कैन राइट इट एज बाय इंक्रीजिंग द वोल्टेज, the current rating will decrease, and by the relation H is equal to I square RT, if I will be less, H will be also less. As a result, less heat will be radiated. A. Answer the following question based on a hot cathode ray tube. Number 1. We have to name the charged particles, and they are what? Electrons, which are emitted during thermionic emission. Okay. Number 2. We have to state the approximate voltage used to heat the filament, and that is 6 volt. Low tension battery. Okay. Number 3. What will happen to the beam when it passes through the electric field? When it passes through the electric field, right? The ray will get deflected towards the positive plate, right? As the electrons carry negative, are the negatively charged particle. B, we have to state three factors on which the rate of emission of electrons from a metal surface depends. It depends on three factors. They are nature of the metal, that is on work function. Okay, lower the work function of the metal, greater is the rate of emission of electrons. Next is the temperature of the surface. Next is the temperature of the surface. Higher the temperature, higher is the rate of emission of electrons. And the third is surface area. Surface area of the metal surface. Greater is the surface area, more is the number of electrons that are emitted. Okay, now C. C is free electrons, right? It's a memory plus topic. Okay, now free electrons. What are free electrons? In a nucleus, the in an atom, the electrons which are closely bound to the nucleus, they are tightly pulled. Okay, so they are called bound electrons. Whereas those electrons which are at a distance from the nucleus, they're loosely bound. Okay, so as a result, when different atoms combine together to form a solid, okay, they become free to rotate in the full surface of the solid. As a result, they are not fully bounded to the nucleus. Got it? So this was the explanation of free electrons. Why do they not leave the metal surface on their own? Because they do not have sufficient energy to leave the metal surface, right? And the next one is, how can they be made to leave the metal surface? We have to state in two ways, and they can be by applying heat, external heat, or by subjecting them to any external electric field or magnetic field. And so we come to the end of this session. Thank you.